Hello, Namaskar. My name is Nand Kumar. I was formerly the head of Radiological Safety Division of Atomic Energy Regulatory Board. Now we will have a discussion on nuclear and radiological emergencies and the state of preparedness. Now this will be the sequence of presentation. First, we will see what are nuclear facilities and radiation facilities. These terms are very well understood by everybody. But for the sake of this discussion, I am going to assign a certain meaning to these terms. Similarly, what are nuclear and radiological emergencies? There should be no confusion in our understanding. Let it be agreed to the meaning that we are going to discuss now. If such an emergency occurs, what will be the possible consequence? It is a consequence that bothers us and demands that we are prepared against it. Now, what kind of response actions should be implemented by us? We will see a list of response actions. And finally, are we prepared? This will be the last part of this presentation. We start with nuclear facilities. See, this picture shows a list of facilities which are connected with the nuclear fuel cycle, like mining and milling, fuel fabrication facility, and the fabricated fuel goes to the reactor. From the reactor, the material, the burnt fuel, come to reprocessing facility where the useful byproduct materials are removed, and then finally, radioactive material, which is of no use, is finally sent to the nuclear waste repository. These are 5 important components of nuclear fuel cycle. So these are the 5 important nuclear facilities which we need to consider. Then what are radiation facilities? Radiation facilities are places where radioisotopes are used for medical purposes, industrial purposes, and research purposes. You are familiar with use of cobalt-60 for cancer therapy. You are familiar with use of radioisotopes like iridium-192, which is used for taking radiograph of industrial products. Like we take medical x-rays, we take x-ray of objects to find out if there are any defect, casting defects, welding defect, etc. And these radioisotopes are also used in industry to serve as a support for process control. Here you see how the thickness of this material, this sheet can be checked by using a nucleonic gauge. You can find a nucleonic source for finding the height of filling columns in fluids, and these radioactive materials can be used for finding if there are any defects in the human body by administering a small quantity of radioactive material to a patient. So these are various applications of radiation, and the facilities where these applications are carried out are known as radiation facilities. Now that we have agreed upon the definition of nuclear facilities and radiation facilities, we'll see what are nuclear and radiological emergencies. There are basically 3 types of emergency. One is facility emergency. This will be normally confined to the facility only. It won't go beyond the facility. It will not reach even the rest of the facility. It won't even cover the entire premises. And consequences will be limited to a part of the facility, not the entire facility. So the entire premise will not be affected. This is a facility emergency. Now, site emergency is a kind of emergency, and the consequences will be limited to the facility premises. The consequences will not extend beyond the facility premises. Whereas in the case of general emergency, such as a nuclear reactor that we see in the picture, if radioactive material in large quantities is released, that can reach the public domain. So that's why we call it a general emergency. Sometimes it's also referred to as off-site emergency. So the consequences extend to public domain. So these are 3 types of emergency because facility emergency and site emergency are expected to stay within the premises, public authorities are not involved, the site personnel will be able to handle this laboratory. We will largely concentrate on general emergency in this discussion. So we'll give a few introduction to various emergencies, earlier two emergencies. Now, what are the possible consequences of the emergencies? Why are we worried about emergencies? Now, we know that there are health hazards associated with radiation. This scary picture is just to show that if very high doses of radiation are received by individuals, these effects are possible. Let us look at the bottom four effects, which are shown in red character. For these effects to occur in an individual, the dose received by the person should be significant. We normally never come across this kind of injuries under normal conditions. Occasionally, in accident conditions, skin injuries have been injured. And historically speaking, even in nuclear emergencies, we have very few cases, if at all, which have resulted in these four major hazards. For interesting thing about these four injuries, skin injuries, cataract, infertility, and death, is that there is a threshold dose for these effects to manifest. That is, if an individual receives that threshold dose or more than the threshold dose, only then these consequences will manifest in the individual. If a person receives less than the threshold dose, then these effects will not occur in the person. That's why they are called deterministic effects. And our effort will be to ensure that these determined effects will never occur. Now, top two exercises, top two examples, cancer and genetic effects. Now, they can occur at any dose. They are probabilistic effects. That is, if this effect should not occur, the dose result should be zero, and there is absolutely no contingency where the person is exposed to zero dose. Even if there are no nuclear facilities, even if there are no radiation facilities, there is radiation everywhere. There is radiation which is reaching us from the heavens, from the skies. They're called cosmic radiations. And there is radiation from the earth. The milk we drink is radioactive. Normally, naturally, it contains a radioisotope called potassium 40, and the building material of which the buildings are made, they are radioactive. They are naturally radioactive. So there is absolutely no chance of ensuring that a person receives zero dose. But what we can do when we take a response measures to ensure that the doses received by individuals are kept to a minimum so that the probability of occurrence of these effects also can be reduced to a minimum. So now we have a line of approach. We know what we have to fear, and we know we don't have to fear because the bottom four effects and similar effects can be avoided by ensuring that the threshold doses are never reached. As far as the top two effects, probability effects are concerned, we need to be careful to ensure that the doses received are low or kept to a minimum. Now, biological effects occur because persons are exposed to radiation. There are two types of radiation exposure. One is called internal exposure, and the other is called external exposure. The difference is easy to understand. Now, let's say in this picture, the person in front of you is having a radioactive material inside his body. Somehow the radioactive material has entered his body. Maybe he was breathing radioactive dust, or he has eaten some radioactive material, consumed the radioactive material. So there is radioactivity inside his body. So this is internal exposure. Any exposure that is received is called internal exposure. And the source in this radiation, in this case, is inside the body of the person. In the case of external exposure, the source of radiation is outside the body. No radiation, no radioactive material inside the body. There is radiation coming from outside. Now we can protect ourselves against external exposure by moving away from a source of radiation, by sheltering ourselves, by hiding behind a shielding material. Whereas in case of internal exposure, if a radioactive material enters the body, it has to be driven out of the body. So we have to control internal exposure this way only. Now, how does internal exposure occur and how does contamination occur, it is because of contamination that internal exposure occurs. Now, let us say some radioactive material is released in an accident. Now, that leads to intake of radioactive material. How does this occur? Let's say there is release of radioactive material. A person is working nearby. Material can enter through a pathway, that is inhalation. Another pathway is ingestion, that is his hand may get contaminated. He may not know it. He may pick up a piece of sandwich and swallow it. So along with the sandwich, even the contaminant enters his body. That is ingestion. Third is absorption by skin. If there is an open wound, radioactive material can enter his bloodstream directly. So these are the three pathways available for intake of radioactive material. In this case, as we saw earlier, the source of radiation is inside the exposed person. Now, contamination. If radioactive material is released in the form of liquid, gas, or dust in the environment, exposed objects like tables, ground, air, even persons who are exposed to these particles, they get contaminated. Now, because of this contamination, the human body uh, intakes the radioactive material, and this intake occurs through inhalation of dust, gases, or smoke, as we saw earlier. Ingestion can occur via the mouth from smoking, eating, or drinking with contaminated hands, and through wounds, grazes, or cuts on the skin. Radioactive material can directly get incorporated in the bloodstream. So this is how internal contamination occurs, resulting in internal exposure. Okay. Now we know what a radiological emergency is, what a nuclear emergency is. We know the consequence of this emergency, so we will have to think of response actions. What response actions should be implemented? If it is a facility emergency, what should be done? It is an event that can reduce the level of safety of workers at the facility. That is, the radiation level may increase inside the facility. So generally it is restricted to part of the facility only. So response actions are taken by the facility personnel, and these are the response actions. Attend to the injured and save lives. This is very important. And secondly, monitor site personnel. And if they are contaminated, decontaminate them and try to estimate the dose that they might have received because of the emergency. If somebody needs medical help, organize medical aid. And then if there are persons present there who are not required to be present, the non-essential personnel or even visitors, they should be evacuated from the site. And confirm that this emergency has no off-site consequence. This can be easily done by going outside the premises and measuring radiation level and contamination level. So these are all the actions the facility person need to take. About site emergency, it can reduce the level of safety on site. It can degenerate into general emergency. If it is not controlled, it will become worse, it will get escalated, and then the consequences can be felt outside the premise, in which it will be no longer a site emergency, it will be an off-site emergency or a general emergency. But in this case, also response actions are taken by site personnel. Again, they have to attend to the injured and save lives. They must evacuate non-essential personnel and visitors from the affected area. Must manage the situation from the control room. They must try to bring the situation under control. Maybe switch off a unit to make sure that radioactive release does not occur, the radiation level in the place is reduced. So they should try to manage the situation from the control room. Then provide on-site sheltering for the people. Inside the premises, there should be pre-designated areas where people who are potentially affected by radiation can be accommodated for a few hours. They should all be sent there. And if anyone needs medical aid, organize medical aid. And if anyone is contaminated, he must be decontaminated and estimate dose of person if they were exposed to radiation. And then alert off-site response actions. Now, this has to be done because, as we saw earlier, it can degenerate into a general emergency. Inform the off-site personnel there is a site emergency. We are controlling it. we expect to bring the situation under control within, say, 1 hour. However, if the situation escalates, if the situation worsens, then you may need to come into the picture. We will keep you informed. So this kind of alert message should be sent to offsite response personnel. So this is as far as site area emergency is concerned. Now we come to the main topic of general emergency. I just give a couple of examples of nuclear emergencies and radiological emergencies. In these emergencies, public domain is potentially affected. And there is a likelihood that public domain will be affected. In a nuclear emergency, let's say there is a nuclear facility. A nuclear emergency normally originates in a nuclear facility, and that can affect the area around it. Whereas in the case of a radiological emergency, if the radiation facility itself per se is not involved, it can be loss of source from a radiation facility. A source which is inside the radiation facility does not cause any harm outside. But if a source is lost, then can reach the public domain. That is an emergency. That is an off-site emergency, a general emergency. If a package containing radioactive material meets with an accident during transport, then that results in a general emergency, radiological emergency. And let us see, this radiological emergency, we will see, is less severe than nuclear emergency, but it can occur more frequently. We will see some more specific example which will help us appreciate the difference. Now, we will see a nuclear emergency example. As I said, potentially affected people, it could be in the public domain. They can be potentially affected. Now, in a nuclear emergency, we take the example of a nuclear power reactor. If an emergency occurs in a nuclear power reactor, it may require extensive response measures. These measures can be severe, but this emergency, this kind of nuclear emergency is very rare. To my knowledge, over the past, let's say 60, 70 years, there have been only 3-4 incidents which could be called nuclear emergency in the public domain. And though they were severe to begin with, they have been controlled. Over the years, world over, the authorities have developed methods of controlling off-site emergencies occurring due to nuclear power plant and nuclear facilities. So though the consequences can be severe, these emergencies are very rare. This is a photograph of Chernobyl facility reactor where severe accident took place in 1986. It's a much discussed accident. You find a lot of information about it if you go to the net. Now, an emergency due to a nuclear material is often called a nuclear emergency. A nuclear material is a radioactive material that is used in connection with nuclear power production, like plutonium, like uranium-235, plutonium-239, they are all nuclear materials. If they are involved in an emergency, they are classified as nuclear emergencies. So this is all about nuclear emergencies that we need to know at this stage. Now we are more concerned about what response action will be called for. Now, I have some specific response actions here. Now, in a nuclear emergency, let's say, as the picture shows from a nuclear reactor, a plume comes out. It carries radioactive material. Now, from the plume, particles may fall and they may be inhaled. These particles may be radioactive. And they can contaminate the environment. They can contaminate the ground. They can contaminate the food being grown. They can contaminate the pasture. If the cow consumes the grass, which is contaminated, the meat will be contaminated, the milk will be contaminated. So these are some of the effects that we need to remember when we talk of nuclear emergencies. Now, what kind of response measures do we have in mind in the case of nuclear emergency? Nuclear emergency response actions are implemented by District collector or divisional magistrate, what does it do? He coordinates all actions done by his people. District police, he is responsible for making public announcement, maintaining law and order. District medical officer, he has to provide health care to public because people may be shifted from the affected village to a safe place. The safe place, they'll be in a camp. They have to be protected there. District transport officer will have to provide transport to people from one village which is affected to a safe village where shelter will be provided. A district animal husbandry officer, he will have to take care of cattle. When you ask people to leave the villages and go to another village, they will be worried about the cattle. In most cases, they refuse to leave unless they are reassured that the cattle will be taken care of. And that will be done by the animal husbandry officer. Now, the civil supplies officer will provide food and ensure safety of people who have been taken to a temporary shelter. And they will ensure that if food is contaminated, food grown in the affected area is contaminated, it does not reach the market. So these are the responsibilities assigned to offset authorities. And there are NDRF, that is National Disaster Response Force, and other experts who take care of radiation monitoring and protection of individuals. So these are the various elements of offset emergency management. We spoke about district police. They are the people who will say, stay indoor. There is radioactivity around. And they will make sure that vehicles from outside the village do not enter the village. This area is potentially affected with radioactivity. Take some other route. Don't enter this village. And then they will evacuate the people from the affected village to a safe place, to a temporary camp. And they will maintain law and order in the affected towns. Now, these are the kind of places which are normally selected for sheltering, like schools, places of worship, cinema houses. If you are in your house, you stay indoor. If you are outside doing some business, don't go to your house. It may be a long way away. Go to a place like this, which is pre-identified as a shelter. This advice will be given by the police through public address system. Now, this is an important aspect of emergency response. Iodine prophylaxis. What does it mean? Important among the fallout in a nuclear accident is radioactive iodine. Now, it may be inhaled or ingested. It may come down, people may breathe, or it may settle on certain food items or water, and when we consume it, it goes to the system. So, radioactive iodine can enter the human body. Now, iron, when it enters the body, it concentrates in the thyroid and it delivers dose to the thyroid. Now, it can be prevented by blocking the thyroid with non-radioactive iodine. This is potassium iodide. These days, we prefer potassium iodate. These are procured by the district authorities. They are kept in local dispensaries and they will be distributed to the public if there is an accident so that they quickly consume it. When this non-radioactive iodine is consumed, this non-radioactive iodine occupies the thyroid. Subsequently, if you breathe radioactive iodine, that iodine will not be able to enter the thyroid because it is already saturated, so that will be thrown out of the system. So this is how thyroid is blocked using non-radioactive iodine. Now we will have to evacuate people to temporary shelter. People are advised to collect their essentials like dress, medicines, baby food, etc. They are advised to assemble at a designated place. In each village, people have been told that there is a pre-designated place. If we make an announcement, you go to a place, go to that particular place, maybe a school, or it may be a cinema house or wherever. They have to go there. And then once they gather, they collect and they peacefully board a bus. A bus will come and pick them up. That bus will take them to a safe place. That safe place is generally described as a temporary shelter. They will stay there for a few days until the situation becomes normal. Now, the cattle, they don't have to worry about the cattle. The cattle will be looked after. This is about evacuation. Now, people have to be transported. So for them, the district transport officer, he organizes buses. In fact, during an emergency, he will have the authority to call any bus owner to stop his service of providing buses to various destinations, send them to me, and they will be used for this emergency response purpose. He will have the authority and power to do it. These buses are commanded by the district transport officer, and people are taken from the affected area to a safe temporary shelter. Now, at this temporary shelter, there will be district animal husbandry officer who will take care of cattle which have been removed, which have been taken from the village, and then civil supplies officer will organize food for the evacuated people. Safe, clean food will be brought by the civil supplies officer. And also, the civil supplies officer will prevent sale and consumption of contaminated food. Now, finally, medical care also is needed. District medical officer, he will arrange for medical care at the temporary shelter and prevent breakout of epidemics. When a large number of people gather in a place, there is a possibility of epidemics occurring. So the district medical officer takes care of that. Now, a general emergency of radiological nature. That's what we will discuss now. So far, we saw general emergency in the case of nuclear facility. We saw how severe and complicated the response process is. We will come to radiological emergency. We'll see what characterizes radiological emergency. We gave the example of loss of radioactive source from the radiation facility and this dirty bomb. The correct technical name is radiological dispersal device or DD, or it can be an accident during transport of radioactive material. As you can see, a radiological emergency will not occur in the facility. When it occurs outside the facility, these are some major examples of radiological emergency occurring in public domain. Now, let us take the example of dirty bomb, which is an extreme case. Now, it is a device using explosive. As you can see, a metallic container has explosives surrounding a radioactive material. Explosives are bought in the market. The radioactive material is normally stolen from a radiation facility. Now this bomb is ready. Once you set the bomb on, it explodes. Then what will happen? What will happen if an explosion occurs? One, there will be radioactive contamination due to radioactive dust. Then radiation exposure can occur in certain circumstances, not always, because the quantity of radioactive material that can be placed in dirty bomb is not very large. If it is large, a person who is preparing this bomb himself will get very high unsafe dose. So normally, the activity used itself will not be high, and in an explosion, the bomb itself will disintegrate the source. So radiation exposure is not a major issue. There could be contamination, and there could be physical injury due to the explosion itself. And in this kind of thing, they will be having non-radioactive shrapnel like pieces of iron, sharp objects, nails, etc. And glass pieces, they can cause physical injury. There could be burns due to explosion. And worst of all, there will be panic and fear. This is the worst consequences of a dirty bomb because the terrorist is not so particular about killing people as he is about causing terror in public. Hence, he is a terrorist. So panic and fear may spread, and then there will be trauma and affected individuals that can last for some time, for quite some time. See, what response measures would be ideal in the case of a radiological emergency? Emergency actions are implemented by first responders. What do they do? First responders are basically police, medicos, and firefighters. They cordon off some area around the affected site and they inform authorities. So they need not be experts. They need not be experts in radiation safety. They know the basics. That this much they can do. If it is a radioactive, if it is a radiological emergency, cordon some area given to them at a pinch, and then inform the authorities, wait for them to arrive. Now there will be disaster response force like NDRF, etc. They will reach the site, they will do the monitoring, they will redefine the cordon, they will provide protection to the public, and they will call experts who will be trained staff. They will do sampling, they will do analyze the samples collected. If areas are affected, they will do the decontamination. All this process may lead to waste, radioactive waste. They will organize waste disposal. So these are the three important components of responders in an emergency. As you can see, medical staff will attend to people. There is police which will prevent entering the affected zone. There will be the emergency commander, incident commander who will be giving instructions to doctors, police, etc. And firefighters can handle fire. They can lift heavy objects. They can take care of hurt people, injured people. There will be public information officer who will be handling the media. So these are the components of first response. As I told you, they are not necessarily experts in radiation safety, but they are good at organizing response. Once they have done all this organization, experts and NDRF people can come, they can handle the emergency. This is a typical scene. The yellow circle inside is the affected area. Let's say that's where a dirty bomb expanded, or that is where a package containing radioactive material met with an accident and got damaged. So that area is likely to be contaminated with radioactive material. If one enters that area, he is likely to get radiation. So that is no one can enter there. Now, people who are attending to the emergency, they will be having their own small camps outside, say a small decontamination area, places, small area where people will be collected and the monitoring will be done. And that is an extended circle that you see outside. It's called the security region. Only security people can enter here. Now, even those people, for entering the yellow region, there should be procedure for making sure that they're properly protected. In a real situation, it may not be so well organized, but this will be the basis on which response actions will be initiated. Now, important part is evacuation and cleanup. The four experts will first shift the people who are potentially affected to a temporary shelter downward. Let us say a dirty bomb expanded. And let us say a package containing radioactive material met with an accident. They expect some contamination in the region. So they'll ask people move some distance to a shelter that will be downward. Now, urgent evacuation. Some of them may carry contamination, we don't know, that has to be checked. Now, cleanup of the affected site will be done. If there is contamination, that should be removed. They'll have to find out what is the amount of radiation hazard. This has to be cleaned up. And then finally, when everything is under control, you terminate the emergency, allow traffic to continue, release the public domain for continued peaceful use. So these are the three important activities, evacuation and cleanup, that will be done by disaster management experts. I mentioned about cordoning. Here are certain blind values. If you think the source which you see on the affected area is a damaged source or it is not within a shield, and cordon about 30 meters. The first responders want only this kind of idea. Now, if you think there is a spill of radioactive material, then cordon about 100 meters around. If there has been a fire or explosion or fumes involving a radioactive source, cordon 300 meters radius. Now, if it is an RDD or suspected bomb, whether exploded or it may explode anytime unexploded, then cordon 400 meters radius all around. There should be no one inside the cordon, but people who are already there, they are the people who should be taken out to the safe temporary shelter that I mentioned the previous, what you see on the right hand side top. If they are already present before the cordon was made, they are potentially contaminated. So they must be taken outside this cordon area. Now, let us say an RDD event takes place. You want people living, already living the downwind area, the direction, up to a distance of 2 kilometers, ask them to stay home, don't come out until you are advised. And in other direction, you ask people not to come out, say up to a distance of half a kilometer. That is, people living within a distance of half a kilometer from the side, in the direction other than downward direction, they're relatively safe. Still, they should stay indoors until they're further advised. Now, when you want to move people to a safe temporary shelter, you must find some good buildings. If good buildings are not available, take the nearest robust building. This must be done to make sure that they don't get contaminated. The first towards action we take, that is vital. Efficiency of the first responders, though they may not be experts, it is the efficiency that is going to produce the best results. So local emergency services like police, medical staff, and fire brigade, they play the most important role in containing the consequences of an emergency, whereas experts come and clean up the area. Remember, it's a word of caution. If you think terrorism is involved, criminal activity suspected, then person that you have moved from the affected area to the safe town, safe camp, where you are going to decontaminate them. First, check them carefully. Make sure that they are not carrying any weapons. Ensure that emergency workers themselves are protected. This is a word of caution specifically applicable to RDD. Now, we spoke about evacuation and cleanup. Now, we said the area affected should be cordoned off. We saw this is done. But you must see, ask the people to leave the site. We also saw they are taken to camp. And then you must clean up the area, which is decontamination. When I say decontamination, how do we organize? It simply means remove contamination. Why do we decontaminate? If we don't decontaminate, the place will remain contaminated. People walking up and down, driving vehicles on the area will spread contamination. And if you decontaminate, you minimize the dose to public and workers through preventing internal contamination. This is why we have to decontaminate. A separate decontamination area for first responders should be provided so that all decontamination activities are done in that isolated area. Now, we must remove contamination, prevent further spread. We must use that workers should wear the protective clothing. We will see a picture of what kind of protective clothing is to be used. It should be a laboratory coat, gloves, coveralls, and self-contained breathing apparatus. As you see, now gamma dose rate measurement should be done like this. The person you see here wearing the green dress is very well protected, but he is an expert, he is an NDRF person. He is going very near the source of radiation. He is going to be working in the contaminated area. Therefore, he has to wear this. But the first responder need not use this. Any available clothing will be enough for him because he is not going to stay in the potentially affected area. This is gamma dose rate monitoring. For contamination monitoring also, we suggest people, you see here, you see the person on your left, he suspect his hand is contaminated. The person on your right is holding a contamination monitor and is scanning it. See, both of them are wearing his protective clothing. This is required for people who are going to work in the contaminated area. They are the response workers, they are the experts. But first responders, they won't be present there for a long time. They do not need this protective clothing. Now, before you decontaminate, you need a criterion. If over the affected area of the human body, if the dose rate is more than 1 microsievert measured at a distance of 10 centimeters, then body needs to be decontaminated. You must use fire hose, soft scrub brush. If it is hard brush, that may hurt the skin and radioactivity may get in through the openings in the skin. This has to be done carefully and detergents may be used. After decontamination, do a resurvey to confirm that you have done decontamination properly. Contamination control over the affected area If the dose rate is again more than 1 microsievert per hour at 10 centimeters, then decontaminate the area. Supposing you find an object showing dose rate of 100 microsievert per hour at a distance of 1 meter, then this object has to be treated, isolated, and that has to be treated as radioactive waste. Now, people working there, they should be instructed not to eat, drink, or smoke in the vicinity. They should go home, change clothing, take a shower. See, for example, if you find out that at 10 centimeters from the body, the dose rate you measure is less than 1 microsievert per hour. Tell the person to have a shower, change dress, wash dress separately because it may be contaminated, and listen for official instructions. However, if the dose rate at 10 centimeters from the body is more than 1 microsievert per hour, then get decontaminated immediately at the site itself. And only if that is not possible, send the person home to have a shower, change dress, wash his dress separately, and listen to official instructions. This is for decontaminating persons who may be contaminated. Now, decontamination of area and persons will produce radioactive waste. You must collect the radioactive waste. Solid waste should be separated from liquid waste and they should be disposed of. A person expert who read the book, they know what the AE or B regulations are. There's regulations of Atomic Energy Regulatory Board, and they will have to dispose of the radioactive waste according to the regulations. Now, there are three principles of waste management: delay and decay, so the radioactivity itself becomes small; dilute and disperse, so that activity concentration becomes less; and concentrate in immobilize, that can be locally disposed of. Radioactive waste generated following this decontamination activity are normally sent to an approved facility of the Department of Atomic Energy for safe management. Are we prepared? Next few slides are very easy to understand. This is the management system in India. For facility people manage. Site emergency people, they will manage. For general emergency, we have district, state, national disaster response forces. The case of national response, we have National Disaster Management Authority. Is DMA-II-2314 mandates the central government establishes an NDA. Prime Minister is the chairman. Chairman nominates members. One of them will be the vice chairman. Under this act, following were established: National Disaster Management Agency, State Disaster Management Agency, TDMA's district, and NDRF. They are all established under this act. Government has to coordinate between ministries and departments, between state governments and various domestic and international agencies who have a role to play, and central government has to make sure that sufficient funds are available. Now, NDA's responsibility is to generate criteria for, uh, for handling an emergency, approve national plans, and they should recommend guidelines for control of exposure to radiation, control of contamination, medical support, everything. So the people who prepare the plans follow the guidelines prescribed by NDMA. This is a structure. We have NDMA at the top, at the central government. Each state has its own SDMA, State Disaster Management Authority. In each state, the SDMA establishes District Disaster Management Authority, and this is how they operate. If there is a nuclear facility or radiation facility, it will be serviced by DDMA through advice from SDMA, who are contracted by NDMA here. Now, as far as district is concerned, it's governed by the district magistrate and district collector, and DDMA is appointed by him. These are the elements, these are the components of DDMA. We saw earlier police, medical, transport, etc. Now, in the case of transport accidents, NDMA it has control over SDMA, SDA has control over DDMA, which will take care of the accident which takes place in the district. There will be NDRF will be attend to the site. Now, as far as DA is concerned, they have established a crisis management group. They ensure that plans for preparedness are developed by all radiation facilities, nuclear facilities, and they update emergency preparedness regularly. They have an emergency control room operating 24/7, and they coordinate with the concerned district authorities and state authorities. They take part in emergency exercises. Now, this is for a nuclear facility. NDMA acts with SDMA, who interact with DDMA, and they take care of the affected area, whether it is a nuclear facility or radiation facility. And DACMG and Emergency Communication Group, they coordinate the response actions. If it is a transport accident or RED explosion, this is the same structure which operates. Now, we saw what are radiological emergencies. We saw the possible consequences of emergencies, biological effect, contamination, etc. Then we saw medical care, cordon, sheltering, evacuation, decontamination, disposal of radioactive waste. They constitute response actions in nuclear emergencies. And in the case of radiation emergency, radiological emergencies, we have this NDRF, SDRF, DDRF, who are commanded by NDMA, SDMA, and DDMA. And this is how we handle various emergencies. Thank you for your attention. Okay. Okay. If you have any questions, feel free to ask now, please. Student can mail also. Okay. You have the option of sending your questions by email, and that will reach me. And I'll be glad to answer every question I receive from you. If there are no questions, I thank you for your attention. If you think of any question, as I said, please do not hesitate to send a mail to me. Thank you. All